This evening I was thumbing through a Italian electronics magazine, and I will give the link in the description of the text box. And on a certain moment in that video I told about Astabile Multivibrator, and I also told, get the bias okay to make such a circuit work. The good idea of that 1969 circuit was that we only need here one capacitor to get to a certain frequency. I changed quite a few values compared to that 1969 circuit in that Italian magazine. Anyway, this is what it is. It's a kind of Darlington setup, don't know that exactly. And of course the two transistors need different biases, and the crux of the bias is this 47K potentiometer. That makes the circuit work. And you can see here this 82 kilo ohm resistor, and here the 33 kilo ohm resistor. That had all to do with keeping the circuit working, generating square waves. Of course, it's all very simple. In modern times we need, or we use, a 555 chip, but this could also be very interesting, for instance, to drive whatever other transistor, a coil, etc. So these are, the minimum and maximum frequencies that I found. 10 nanofarad is 18 kilocycles, and 1 microfarad we are on approximately 200 Hertz. So this is the circuit on the breadboard. Very easy. I don't want to pay too much attention to this circuit, and then I don't want to make the video too long. It now works on 24 volts. That's also a good idea of the schematic. It works from 6 volt to 24 volts, and I'm almost sure it will also work on 5 volt. Well, let's try. Perhaps that's interesting for everyone working with Arduinos, etc. So now we have nothing here, no oscillation. This is, the frequency that the counter remembers, so it doesn't have to say anything. So let's go to the minimum voltage where this starts to work. Well, it is 3 volts, as far as I could see here. 3 volts. Feel free to experiment. Here 3 volts, and we have here that waveform. We are on 206 Hertz. Not bad. Let's try what it can make when we change the bias on 3 volt. So 3 volt is okay for, an Arduino or so. So I change the bias now here. This is the pot meter that changes the bias. The 47K. Let's see what happens. Frequency and waveform. Change the bias here now. 263 Hertz. 137 Hertz. Put up the amplification of the scope to get a better insight. So, well, I think it's a useful circuit for all kinds of purposes. And let me show what happens when we get to the higher frequencies, say the 18 kilocycles range. That's here. 13 kilocycles. Of course, we need to adapt the scope a little bit. 13 kilocycles. This is the waveform. Is it perfect? Well, not perfect, of course. The duty cycle differs. Anyway, again, let's do the biasing here. And that biasing, of course, has an effect on the duty cycle and frequency. So that makes such a two transistor circuit interesting. I turn now the bias 24 kilohertz. This is a waveform. That's of course not bad. Change the bias again. Let's see what happens at the same time on the scope and the counter. 16 kilohertz, 12 kilohertz. So that 9069 circuit is, in my opinion, a useful circuit. Thanks for watching. And again, we were now on 3 volts. So let's go to a higher voltage and see what happens. That is perhaps also interesting. Well, no, not so much more changes. We are on 21 kilohertz approximately. So it is a versatile, properly working electronic circuit, useful for all kinds of applications. Thanks for watching.